Uh, Today, we are on the cusp of entering 2021, and I'm quite sure that you would have had a good Christmas, and we wish you the very best for the new year, and we hope that the new year would be much better than what the current year was. So today we are going to have a very interesting talk on digital supply chains, especially supply chains as it is, where always an issue of getting efficiency by having better supply chains. And in the recent past, due to the COVID-19, there is a lot of digitalization as well as digitalization which has taken place. So it is very important for a manager to understand about what this is all about. So we are going to talk about supply chain 4.0, which is a synonym for digital supply chain. And Professor Pratap Sundar is going to talk about a framework for supply chain 4.0, understanding digital continuity, impact of new technologies on supply chains, the benefits of the digital supply chains, and an example of this. And let me tell you, there can be no better person than Professor Pratap Sundar. He is presently the academic director of Munjal Institute for Global Manufacturing and Punj Lloyd Institute of Infrastructure Management. He is also the adjunct professor of operations management at the Indian School of Business. He has had more than 3 decades of experience as a teacher, trainer, consultant, and director of a manufacturing company in USA. He holds a BTech in mechanical engineering, an MTech in industrial engineering, and a PhD in industrial engineering, again from Northeastern University, Boston. He has also received a training in the theory of constraints from Dr. Ellie Goldratt at Boston and training in axiomatic design at MIT, and also training in aircraft initiative again at MIT, Boston. So there can be no better person than him to take you through this. And he also has a penchant for exploring nature and linking it to science. You will find an example of that. Professor also teaches at the Advanced Management Program for Manufacturing and Operations at ISB, which is slated to start on 29th of Jan 2021. And he will be linking to a large extent, trying to showcase as to how and what he teaches during the program, and also link it with today's session. So thank you very much, and I hand it over to Professor Pratap Sundar.
Thank you, Rajiv. I am very thankful to you for the nice introduction, and good evening to all the attendees. Are you able to see my PPT?
Yes.
So today, for about 2 hours, I would like to share the concept of digital supply chain and the technologies that are driving this paradigm shift in the not only in the supply chain but also entire range of industries encompassing not only manufacturing but also services, infrastructure, and transportation sector, and so on. So if you observe Google Trends in the last 35 years, many Indian companies have implemented Lean, and about 40 companies have won the Deming Prize, which is the highest prize awarded for TQM and also Lean initiatives. So if you see the Google Trends, what is happening in India, this is the data about what is current thinking in India. The interest in Lean is waning. The interest in Industry 4.0 is gaining a lot of momentum. The orange line indicates a decreasing trend that is related to Lean, And the blue line indicates the Industry 4.0 trend. So this is natural because I'm sure all of you would be knowing the meaning of Industry 4.0. This is Industry 1.0 started with mechanized production using steam engines. Industry 2.0 is related to mass production and assembly lines running with electricity. Industry 3.0 mainly focused on automation with the IT and electronics. And Industry 4.0 mainly is centered around connectivity with various technologies that we are going to see. And if you want to understand the concept of these revolutions, Industry 1.0, 2.0, 3.0, 4.0, and so on, I request you to read, I don't know how many of you would have read, The Structure of Scientific Revolutions by Thomas Kuhn, a professor at Harvard University. So the structure of these revolutions can be divided into three phases, which you see on the left-hand side of the slide. In the bottommost, there is a crisis, then there is a revolution, then there is a normalization. For example, the crisis for lean was conservation of resources, doing more with less. That was the concept of lean. And the revolution initiated by Toyota, which the company which shared much of their knowledge, published in many, many books and also thousands of research papers, initiated a lean revolution about 40 years ago. First company that implemented lean systems was Lucas TVS Madras body plant, Chennai plant, which I visited in 1986. Then normalization happens. If you apply this concept, the crisis is, in spite of implementations of lean, there has been a lot of crisis with respect to fragmented supply chains, disconnected machines. So all these things led to a Hanover Fair report, which was published on April 8, 2013, where the word Industry 4.0 was coined and presented. Then the explosion of smart devices and connectivity, big data, platform softwares, artificial intelligence, 3D printing, and so on. All these things exploded in the last 5 years, okay, very accelerated phase. And experts are guessing that by 2030, about 50% of all companies' supply chains will be towards, it will be digital supply chains. So I request you to read this book in order to understand what is happening, what could be the crisis, what is the revolution, what is the normalization, and when the normalization is going to take place with respect to digital supply chains. Whenever there is a paradigm shift, for example, on the x-axis, we have timeline, on the y-axis, we have productivity and quality. So the craft production was having a lot of quality problems and also low productivity. Mass production increased the productivity and also quality. And then the lean dramatically improved the concept of quality, delivery, cost reduction, and so on. And Industry 4.0 is, or which is also called Fourth Industrial Revolution, is ushering a new era in terms of productivity and quality, delivery, and cost, and so on. So you would have heard these words: supply chain 4.0, logistics 4.0, warehousing 4.0, service 4.0, and so on. So they all encompass the same concept, that is digital supply chain. This is the overall diagram of the traditional supply chain, where where it has many sub chains. For example, design chain, starts with the concept of a product, then prototype, then analysis, and engineering and tooling. Manufacturing is part of supply chain, where raw materials are purchased, products are manufactured, and the fulfillment is done, which involves moving, storing, and selling, and billing is done, and the service is provided, something like after sales service. And before the on the left hand side of the supply chain, there is a supplier relationship management. On the right hand side, there is customer relationship management, and so on. So there are so many sub chains. We will not discuss all these things, but generally supply chain means you buy raw materials, you make the products, you move the product, store it, sell it, bill the customer, and provide service. This is the concept of supply chain. It encompasses all the activities associated with flow of information and goods. And the stakeholders who are involved in the supply chain are manufacturers and suppliers, transporters, warehouses, retailers, customers, and so on. Basically, there are three flows. One is in the supply chain. One is material flow, another second one is information flow, third is finance flow. So you can relate this to Lean Six Sigma. For example, Lean Six Sigma teaches how to reduce 8 types of wastes. So these wastes are inventory, excess processing, overproduction, transportation, motion, excessive motion, and so on. If you apply it to digital world, the similar 8 ways you can discover. For example, defects in data. There are many companies have a lot of data, but it's all having a lot of errors, inconsistencies, and so on. Excess processing, unnecessary steps involved in a workflow. Overproduction, a lot of unnecessary data, junk data is created. Waiting for data or information, that also happens. Inventory, data is viewed as the inventory here. The data is in servers, but never utilized for the business benefit. We are going to see beautiful examples related to that. Then transportation of paper documents. Still, many companies use a lot of paper documents. Very few companies can claim that they are zero paper companies. Similarly, motion, a lot of manual work like manual signatures, approvals, and so on. Non-utilized talent is also, people might have some creative thoughts, but about the digital world, but they may not be encouraged. And if you look at the toolbox that we have for Lean Six Sigma, I'm sure most of you would be knowing the statistical process control tools, the total productive maintenance tools, pull systems, leveled production, which is called Heizunka, Pokayake, which is known as error proofing, fail proofing, value stream mapping, Zidoka, and-ons, single piece flow, and so on. For the quality, we have Six Sigma in manufacturing, Six Sigma in transaction process, and design for Six Sigma. A lot of tools are available to implement Lean. For example, value stream mapping is one such tool. Pokayake is one such tool. And when you come to Six Sigma, a lot of tools are there. These tools help companies to implement Lean Six Sigma. When you come to the digital tools, industrial Internet of Things, big data, analytics, 3D printing, augmented reality, virtual reality, machine learning, deep learning, digital twin, blockchain, robotics, and so on. All these tools are available. So why I'm showing this slide and the previous slide is that there is a lot of similarity between Lean Six Sigma and digital supply chains, both of which want to increase the productivity, reduce the defect rates, reduce the delivery lead times, and so on. One of the key concepts that you must understand is digital continuity. Digital continuity refers to the whether we have connectivity in terms of data or not. If you understand Lean Six Sigma, the entire thing can be summarized in 5 words. What is the value that you are delivering to the customer? What is your value stream? Do the products and services flow? And do you have a pull system in place? And do you have perfection? Perfection means quality. The perfection can be measured with respect to internal PPM, external PPM, and so on. Apply the same concept. The most important word among these 5 words with respect to Lean Six Sigma is flow. That is the key word, whether the product is flowing or stagnating. In the digital world, also this concept of flow applies very much with respect to material, data and information, and financial flow. And this is the basic diagram of digital supply chain or digital manufacturing or digital service organization. And the bottommost layer, we have what is known as perception layer, which is related to a lot of sensors, actuators, RFID tags, and so on. Then we have transmission layer. What data is collected by the sensors must be transmitted over a network. Then you have middleware layer where cloud, for example, cloud computing, cloud storages are referred to. Then you have application layer where you have some apps. You have some apps built into the built for using the data for decision making or deriving inferences and so on. And the entire on the top we have business layer, that is a business model which drives the entire architecture of digital supply chains. I'll give one example. See, this is an actual factory which I guided for several years. See, these are machines are there. There are sensors, but they are all not connected. Each individual machine is an island by itself. And people use a lot of paper, a lot of data is collected manually and compiled into PowerPoint presentations for weekly meetings, monthly meetings, quarterly review meetings, and so on. So, for example, if you take one machine, there could be 16 types of losses. Now, with the industrial Internet of Things, the embedded sensors automatically collect all these things, send it to a port, and then the data is automatically by algorithms compiled into nice presentations, and people need not waste time in crunching data, making graphs in Excel, and then embedding them in the PowerPoints and so on. So the entire, whether it is a manufacturing company or supply chain, these are all centered around 3 words. Whether on the top layer you can see instrumented. So whether it is instrumented, interconnected, or intelligent. So these are the 3 keywords that you must remember. Whether instrumented means sensing something, sensing the temperature, for example, or the driving time, or the location of a truck in the logistics, and so on. Whether this device the sensor is interconnected, and whether you have algorithms, intelligent algorithms to manage, all these things. This is a typical assembly line. So at the end of the line, we know the productivity, but really what happens at each workstation, we don't know, because there are no sensors to measure the cycle time of each workstation. And the entire line is a blind, isolated island. So we don't know at the end of the shift or every hour we know something, but minute by minute real-time data doesn't exist because there is no there is no sensors to measure various things. So I want to share with you some examples of digital continuity. For example, truck turnaround time. So truck enters, truck leaves the factory premises. So the time elapsed between truck in and truck out is called the truck turnaround time. So these are the various steps involved. Trucks, empty trucks enter the factory, then weighing has to be done, then a loading slip has to be prepared, then the truck waits, then material is loaded or product is loaded, then again weighment has to be done. All the necessary paperwork has to be prepared, such as road permits, the packing slips, and so on, and the truck leaves. So uh, this in one of the companies I guided this project as a Lean Six Sigma project, not now, 13 years back, before the industry 4.0 technologies have come. So laboriously they reduced the truck turnaround time from 3 hours to 90 minutes. But if there is digital continuity, that means there are sensors on the truck. There are sensors at every step in the workflow of the truck turnaround time path. So when there are sensors, you don't need any paper. Automatically data is collected, automatically it is tabulated, automatically graphs can be presented. In the real time, you have the information. I will give another example. I belong to a place called Tirupati in South India. From Tirupati and our area is very famous for mangoes. One company exports mangoes to Japan. See, in mangoes are loaded into the container. Container is a refrigerated container where the temperature has to be maintained at 18 degrees centigrade. Now, with with IoT technology, we can get the digital content. That means from Chennai, the ship carrying the mangoes, it goes to Singapore, and the Singapore to Tokyo or Osaka. Throughout its path, we will know process parameters inside the container, what is happening inside the container, because the temperature is very critical. And if the refrigeration system fails, immediately the alert should come so that the product, which in this case is mango, can be protected. And in good quality, it can be delivered in Japan. So imagine the sensors inside the containers and connectivity established with the stakeholders, such as the shipping staff. And then in the real time, the data is summarized. And if there is any deviation from the norm, such as, for example, refrigeration has failed, or the temperature has gone beyond, no, let us say 20 or 22, 25 degrees, much away from safe 18 degrees, it can be immediately alert will come and corrective action can be taken so that product can be protected. This is one example. Another example I want to, these are all real examples from my own experience. One of the companies in Tirupati, their product, the home inverter has failed in Rajasthan due to high temperatures. Now this happened about 15 years back. The returned product is called product recall. So they came back to the factory for rectification and repair. The truck driver actually stopped somewhere in between and stole. He has stolen a few inverters. Instead, in the cardboard boxes, he has kept bricks. But nobody knows what is happening to the truck when it left Rajasthan, when it reached Tirupati, Digumagam, a small village where the plant factory is located. What I'm trying to say is there is no digital continuity. There is product continuity. Product is being transported from Rajasthan to Tirupati, but we don't know what is happening to the product. We don't have any information. Imagine the home inverters have sensors and they are transmitting their location. I mean, not the truck. Uh, I am talking about the product on the truck. We need to have sensors so that you have real-time information about the safe return of the product. Another example from my own experience I would share. These are LT panels manufactured by one company in Tirupati. They are huge. Per truck, you can load one LT panel or two LT panels. So the LT panel has, the truck is loaded with two LT panels. One should be delivered at Kolkata, and that should be delivered at Guwahati. That is the shipping plan. But unfortunately, what happened was the LT panel that was to be delivered at Kolkata is deep inside the truck, and the one that is at the door, main door, back door, is the LT panel that was to be delivered at Guwahati. So nighttime around 2 o'clock, 2 a.m., the driver reached Kolkata. They were all feeling sleepy, and then they just unloaded whichever is nearer to the back door. That is the LT panel meant for Guwahati. And then truck left, and after reaching Guwahati, the people discovered that that is the LT panel for Kolkata, which reached Guwahati. I cannot explain how much crisis this has created, and top management, involved, in getting back the product from Kolkata. They were not releasing unless you deliver that LT panel here. We will not give you this. So like this, so much cost of poor quality. It runs into lakhs if you account for the time spent by top management. So what is digital continuity here? Okay, the product should have a RFID tag. When it is loaded, it should be scanned, and there should be a procedure in the shipping document that the LT panel that is meant for Kolkata should be closer to the back door. The LT panel that is meant for Guwahati should be behind. So these kind of things can be achieved by sensors and the revised procedures. So what is there on the truck? Where is the truck? Where is the truck? Where is the I mean, according to GPS, where it is traveling in real time, and the product at what time it was delivered at Kolkata, which product was delivered. So all these things can be digitized. What I am trying to say is that there can be product physical continuity, but there may not be digital continuity unless you embed sensors and collect data and so on. So I will skip some examples. Let us come to the basic idea of digital supply chain. Here, what you are seeing is 4 quadrants. So on the quadrant one, you see traditional supply chain. Okay, there can be on the left-hand side, you can see old technology and new technology. Now, on the right-hand side, you see the digital supply chain. So the old technology, such as ERP, is many supply chains. Almost all the supply chains have implemented ERP. That is a old technology. Now, there are many technologies that have come in the last 20 years and in the last 5 years at an accelerated phase are the keys which transform a traditional supply chain into a digital supply chain. I have left quadrant 2 and quadrant 3 blank. For example, I will give you one example. The new technology, for example, new technology, smart connected products, how it will enable digital supply chain, or how it affects digital supply chain, and how it transforms traditional supply chain into a digital supply chain. For example, this is a manufacturing line delivering batteries, the lead acid batteries. And the lead acid batteries, there are automotive batteries, there are two-wheeler batteries, there are industrial batteries meant for telecom, railways, and so on. Imagine the cell towers, more than 5 lakh cell towers are there in India. And the battery, if the battery doesn't have any sensors to tell about its health means battery health, and suddenly they may fail and the cell tower goes non-functioning into the non-functioning mode, and uh, people suffer because of lack of service. Now, if you implement battery management system, this is a sensor based technology. It's not very costly. For every battery this can be installed. I am giving one example. There are many companies who sell the battery management systems, BMS. So Bosch is one such company, and it has sensors. It has an electronic integrator. It constantly senses the health of the battery. See the life of the battery. Health is sensed in terms of temperature, voltage, and current. And life of the battery is sensed by the number of charge discharge cycles. So the sensor constantly monitors this, and then these are the technical specifications. You need not bother. You can read all these things on Google. They are available. This is the microprocessor inside the battery management system, which takes the sensor inputs and does the analysis and then sends the signal alert. For example, battery might be leaking. You do not know the battery is on the way to the customer, but actually the battery started leaking when it is on the truck during logistics process. So after reaching the customer site, the logistics people realize that batteries are leaking. The customer will not take it because the leaked battery is defective. So if you there is one great factory in Tirupati, that is Amaraja Batteries Limited, for which I have been consultant for the last more than 25 years or so. So they make about 100 million, 40 million batteries per year. So automotive batteries, 6 million in one factory, another factory, 8 million. Small batteries division, that is two-wheeler batteries, about 4 million. So industrial batteries, about 100 million ampere hours, and so on. Tubular batteries, around 4 million tubular batteries, and so on. About 40 million batteries are manufactured per year. In the last 10 years, if you calculate, there are more than 400 million batteries, about 40 crore batteries on the roads with the customers or in locations like cell towers across India and across the world also. They export to Japan, Malaysia, Thailand, Middle East, and so on. And my point is this. If you demand planning, I'm sure most of you will know what is demand planning. And there are many softwares with the built-in mathematical and statistical models. Once you give the data, past data, they will do the analysis based on the trend, seasonal and cyclic and random effects. For example, Box Jenkins or moving averages or exponential smoothing and so on. Many models are embedded in these softwares. They are readily available. But your forecast accuracy will greatly affect the supply chain performance. When you use past data, when you cannot use the current real-time data, your forecast accuracy will be low. Suppose the battery management systems are installed on every battery that leaves the factory, and the batteries, they send their remaining life cycle, for example, or the health conditions of the battery. They send this data, and that will be huge data. It will not be humanly possible to analyze that huge data. And you need to use the Industry 4.0 technology, such as the big data and machine learning, to analyze this data and give alerts. For example, a customer has a cell tower. Let us say BSNL has a cell tower. These batteries supplied by Tirupati factory are installed there, and they are coming close to the charge discharge cycles. That means life cycle. They are, let us say, warranty period is 5 years, and it is approaching the end of the life cycle. The company supply chain can alert the BSNL. You see, your so and so cell tower, the battery needs replacement in another 1 month. Would you like to place an order? Something like that. What happens is, when you have real-time data about the products that you have sold, how they are performing in the market, in the field with the customers, how they are health condition, what is their health condition of the products, do they need some maintenance, do they need a replacement, and so on, your forecast accuracy greatly improves. You need not, you can always use the past data, but also you must use real-time data. Real-time data will not be possible without a digital supply chain. So the demand planning becomes more accurate, so that supply chain cost will be less, efficiency will be more, productivity will be more, and so on. So, and also the stock, for example, how do you take stock? It's all manual processes before the Industry 4.0. People waste a lot of time tracking the products in the WIP area, finished goods, and then loading them onto the trucks. Which product is loaded? Are you sure that the right product is loaded? So all these things are not done before the digital supply chain. A lot of paperwork. Why all this paperwork? No. Why so many people are there? What are they doing? No, all these things will be less with the digital supply chain. This is the logistics system. And then when the truck leaves, how many pallets are there? How many pallets they have gone along with the shipment? How many pallets are returned? Do the pallets have sensors? Are there any pallets missing or stolen or discarded or damaged? No, all these things. So all these sensors, machine-to-machine communication, thing-to-thing communication, all these things will be very, very part and parcel of digital supply chains. This is myself on the right-hand side, along with Dr. Ramchandra Galla, who is the chairman of Amaraja Group Companies. I had the privilege of being an advisor and a trainer consultant for the last 25 years to the group, who I think they have about 16,000 employees and with a turnover of about 10,000 crores or more. That is one example. What was my previous example? Please recollect what a smart connected product can do to a supply chain. What benefits you will have with smart connected products. That's one example. Second, let us come to the service design. I give one example, that is the IoT enabled vending machines. See, these quadrants, please remember that new technology is the enabler. If there is no new technology, supply chains would have been traditional supply chains only. If the new technologies are not there, we would have been where we were. But because of the availability of advent of new technologies, the architecture of the supply chain is changing very fast. Let me give this example, IoT-enabled vending machines. Now, these vending machines are IoT-enabled. That means there are sensors. The customers pay by their digital wallets, and there is a zero-touch experience. You need not press any button. There is a facial recognition if you want to. There is so many things. It's a living thing with a lot of sensors. And then now the question comes, is it a vending machine or is it a data center? It is both actually. Prior to digital supply chain or prior to Industry 4.0, the vending machine is a vending machine, manual vending machine. Now it is an intelligent vending machine. It can manage it by itself. So that is, you can view vending machines as data centers, not merely as physical vending machines. What you can do once you have digital vending machine, operations management, inventory management, transaction management, digital advertising on the vending machines, and so on, platform management, so on. So many things are possible. So, and also you can do customer analytics. Which customer has come how many times repeatedly? If the customer has not come, why has not come? Why she has not come? Or what are the customer preferences? How you should change your product portfolio on the vending machines based on the demand that is displayed by the data. So these vending machines are transforming. For example, on the Google, I request you to read Costa Coffee vending machine design, how they designed the vending machine, how the IoT enabled vending machine was designed. A beautiful case study is there. You can access. You can just type Costa IoT enabled vending machine case study. It will come. This is the first vending machine that appeals to all 5 human senses. No, I am sure all of you know what is the difference between taste and flavor. So these are the things: touch, taste, smell, and hearing something. When there is a digital advertisement, how do you hear? And if there are no customers around the vending machine, this Costa Coffee vending machine, it knows that there are no customers, and it knows how far the customers are. Are they 10 feet away? Or 15 feet away? Then it plays a nice music to attract them. So, and a nice video and some smell. It can transmit some smell, coffee smell, which can waft through the air and then attract customers. So it has appeal to all 5 human senses. It has a 28-inch touch screen, and it has attract mode. When there are no customers, how to attract? It has the intelligence of its own, and dynamic branding, dynamic pricing. It continuously changes based on the customer preferences. Product portfolio is not fixed, and everything you can change because everything is digital. There is no fixed posters or touch screens. I mean, in old vending machines, there used to be buttons with logos of the products. Which product? If you select a product, you have to press that button hard. Then you have to insert the cash. Then the change will be given. No, sometimes the bottle or the beverage doesn't drop easily. Then you kick the vending machine 2 or 3 times. So many things. No, but this is a very revolutionary design. Now, Coca-Cola, for example, to give you one example, 1/3 of all the vending machines are already IoT enabled. They have become intelligent vending machines. And then in future, there won't be any manual vending machines in future. I mean, it will be all intelligent, smart vending machines. What supply chains like Coca-Cola realized, or Costa Coffee realized, because of the smart vending machines, there is 5% increase in division, one division. There is 15% supply chain cost reduction. There is 5% projected savings in the equipment loss from theft. Now, people steal the vending machine itself. We don't know. People steal the products in the vending machines. We don't know. But with these IoT-enabled vending machines, these are the benefits. And if you look at the number of vending machines, there are 2 million vending machines in North America, 1.1 million in Europe, and 1.1 million in Asia. And the projected growth of vending machines is from 4.2 million in 2019 to 8.9 million in 2024. It's growing at the compound annual growth rate of 16.3%. So that is one example of service. How do you provide service with intelligent vending machines? Now, if you come to the supply chain, there is a demand planning. There is a capacity planning. Capacity planning means your manufacturing capacity or service capacity. And there is a factory planning. That means detailed schedules are to be released. Then there is logistics planning. So all these four major modules are part of supply chain. There is also a concept called bullwhip effect. Some of you might be knowing how the variations amplify as you move from customers to manufacturers upstream. The variation, customer demand variation, will be amplified by the retailer, is further amplified by the distributor, is further amplified by the manufacturer when he buys raw materials. This bullwhip effect can be very costly to supply chains because of inventories. Why this happens? Because the supply chain modules are fragmented. There is no real-time communication between the various entities of the supply chain, such as manufacturer, distributor, retailer, customer. And the products themselves are dumb. They don't tell anything about them. Once the product is smart, then it can tell, yes, I am sold. No, that kind of intelligence is lacking in the. So if you analyze why there is bullwhip effect, there could be a lot of reasons, but main reason is lack of communication, lack of information, lack of data in real time. So when you go for digital supply chain, the effect of bullwhip effect can be reduced. It will not be eliminated, but it can be reduced because there will be customer demand, variation in customer demand. It cannot be constant every day or every month or every hour. That is how the digital technologies will minimize the effect of the bullwhip effect. Then I want to give another example. What we are covering, please remember these four quadrants. What is the traditional supply chain? What is the digital supply chain? What is the old technology? What is the new technology? Now, if you understand the new technologies, then only you can plan your transformation towards digital technologies. Otherwise, you cannot plan. I will give another technology, new technology called 3D printing, which is also known as additive manufacturing. Now, on the top, you see the traditional supply chain. There is a supplier's supplier. That means he could be tier 2 supplier. There is a supplier, tier 1 supplier. There is a manufacturer. There is a retailer. There is a consumer. This is the traditional supply chain. When you can print your product, the manufacturing becomes very simple. So 3D model provider, the 3D shop supply chain model is displayed in the middle of the slide, which you can see. 3D printing is downloaded. There is a 3D shop where the product is manufactured and it is delivered to the consumer. In future, suppose 3D machines become ubiquitous, they become smaller and they cost less. Consumer himself can print your product. Only you have to sell your digital file, which is your product. Then the supply chain becomes much simpler. The bottommost diagram in the slide, you can see home printing supply chain. Now, the technology called digital supply chain, how it is changing the architecture of, 3D printing, and the technology called 3D printing, how it is changing the supply chain itself, you can see. Now it is happening in many products, in many manufacturing methods. And the 3D printing supply chain has these are the factors that affect the supply chain: design complexity, lead time, time to market, lesser materials, closer to the market, be nimble and agile. And Amazon has got a patent. What they have done is that they want to put the 3D printing machines on the trucks. This is the patent. So they have identified among millions of products that are sold on Amazon.com, they have identified the products that can be 3D printed. So the truck will have the 3D printing machine once the order is received by the customer, the truck starts moving and the product is manufactured while traveling, while the truck is traveling. So you can deliver the product faster and you need less lead time to deliver the manufacture and deliver the product. Amazon has more than 2,400 patents, and this is one patent they have got you know, uh, of the radical supply logistics process using the technology called 3D printing. Now, big data. Big data is another technology. Now, big data is huge in terms of volume, variety, velocity at which data is generated, veracity means quality of the data, and the value of the data. So these are the four characteristics of big data. And to the example which I already mentioned, Amara Raja Batteries Limited, the company which manufactures 40 million batteries per year. So if you look at their products in the field, let us say they have 400 million products, and you collect data every hour, 12 times every hour, and it comes to roughly 115 terabytes per day. Now that is the big data. Now 115 terabytes per day, no human being can process. We need analytics. So analytics is based on artificial intelligence, such as neural networks and so on. So the analytics programs will be processing this 115 terabytes of data per day and give the inferences or make decisions that by themselves. They can make decisions automatically, or they can suggest a decision which human being can make or modify, or reject. So big data means you must understand the huge amount of data which is impossible for human beings to process. Therefore, we need the neural networks based analytics programs to make inferences and decisions. So, for example, in Amara Raja case, the products, once the products are smart and intelligent, the product portfolio, they can tell potential failure of the product, so that you can alert the customer for replacement or repair or whatever. Product design itself can be seriously improved, greatly improved by the data, big data that is you are getting from the field about the health of the battery. Your demand planning, forecasting, they will radically change and increasing the accuracy. Your purchasing product procurement costs can be reduced. Your production planning, I'm going to give you an example in a minute, can be simplified. Your logistics planning can be monitored in the real time. Your inventories can be reduced. Another example about the big data. For example, General Electric has made their engines smart. Smart means with a lot of sensors, which can sense the health of the engine, the fuel consumption of the engine, the reliability of the engine, the potential failure, which comes under predictive analytics. For example, a flight taking off at New York and reaching Los Angeles, in the 6-hour flight, a Boeing 373 engine generates about 120 terabytes of data. This data can be analyzed to reveal every aspect of the engine's performance and health. But analyzing these 120 terabytes by human beings is impossible. Therefore, you need artificial intelligence algorithms. This example I wanted to tell you, share with you to make the big data. What is big data? That the concept must be very clear. Okay, cell phones also has about 30 sensors. Whoever is using the cell phone, imagine Apple or the other manufacturers, They can collect a lot of data about you, your usage patterns to improve the product, take the product to the next level, and so on. If you look at Amazon, for example, 120 million different products are sold on the Amazon website, and 145.2 million users access Amazon every month, and 44% of the users, shoppers, buy electronics via Amazon, and 67% prefer buying through a desktop or a laptop. So this is an example of big data. Definitely you need analytics engines to process this, to give you the inferences, to give you the decisions, to give you insights so that you can improve your business performance. Next example I want to give you is the new technology, artificial intelligence for planning and scheduling, which is part of the digital supply chain. Now, this is the factory planner. Okay. The factory planner is a software. So there is capacity allocation is the input, assembly schedule is the output. Okay. So before the digital supply chain, what was happening? Imagine Amaraja Batteries Limited. This company has factories in Tirupati and warehouses across the world. Let us confine our discussion to India only. And all OEMs, original equipment manufacturers, buy these batteries. Batteries are bought by not only OEMs, but there is aftermarket and so on. What was happening before digital supply chain was that rolling sales plan is received on 19th of every month by the marketing department. Rolling sales plan is based on the customer demand and the stock levels of various types of batteries. They have 600 variety of batteries. Product variety is 600. So it is received on 19th. Then field stocks have to be collected, which takes 2 days. 21st, that work is completed. And on 22nd, receive capacity allocation and field stocks data from the marketing department, and the purchasing ERP purchasing procurement module in the ERP process this and releases the MRP schedule for placement of various purchase orders for A class items and B class items. On 25th, this happens. On 29th, the assembly schedule is released, is made and released to the shop floor on 30th. That assembly schedule is for the next month, which means that first of next month, the production details schedule will be there for first of next month onwards. Now, if you look at this whole thing, what you can see is that the schedule which is released on 30th for the next month is based on the data of 19th of the current month. From 19th to 30th, 11 days, the field stocks would have changed. The customer demand would have changed. Customer needs would have changed. 11 days is too big a time. The inventories of some products would have depleted. The inventories of some products would have remained the same. I'm talking about the warehouses, pit shops, and so on. Now, this is a highly inefficient, the process, because you are planning something based on old data and releasing the schedule to the factory shop floor. So you will be manufacturing the products that are not needed by the field, by the warehouses, by the customers, and you may not be manufacturing the products that they need. That is the problem. So inventories go up, and of unwanted products, and the inventories are not there for the wanted products by the customer. Ultimately, company suffers. Suppose we have digital supply chain. Now, how much that 11 days of the previous slide should be? I can collect data in real time and complete this entire work of receiving this rolling sales plan, collecting the field stocks. A capacity allocation can be done by an algorithm based on artificial intelligence, which can be approved by a human being. And release of MRP can be done by ERP, plus approval by human beings. Assembly schedule can be prepared by artificial intelligence algorithm, finally checked by human beings, and then released to the factory shop. The entire thing can be compressed into 15 minutes, not 11 days. So what happens is you become more responsive. I mean, you'll be making the products that your customers and field, your warehouses and field personnel need, and you will not be making the product that they don't need. So your efficiencies go up, your costs come down, and your revenue goes up, your profitability goes up, and so on. So this is the advantage of digital supply chain. Next, I want to give one example about analytics. Analytics, see, on the left-hand side, if you look at the how it was done before digital supply chain, it is called traditional empirical analysis. Usually, this starts based on what data is available, what data are available, what information can we learn from this data, and what insights can we generate with this information, and how do we use these insights to make decisions. That was the old model. But with the digital supply chains and advanced analytics, what is the new model? What are the critical on the right hand side? Please look at the right hand side. What are the critical decisions we are making? What insights do we need to make these decisions? And what information do we need to get these insights, and what data we need to collect? So it is exactly reverse of the previous model. And that is the reason why analytics plays such an important role. Obviously, analytics cannot be implemented without big data. Big data cannot be implemented without the sensors placed in various entities of the supply chain. Let me skip some of this. This Amazon Web Services model, and many things are simplified now. You don't need to learn coding also, like such as Python or so. The coding also, there people are automating coding also, which means that it's called low code or no code. So this Amazon Web Services model, you collect data, you select a machine learning problem, and then you collect data. You have data, for example, from the big data. You do some cleaning, preparation and cleaning, then feature engineering is done, then model training is done, and model deployment is done, model hosting is done. So these are all the things that are already available, technologies are already available. And if in your companies, if you want to go toward digital supply chain, please remember, I want to caution that don't develop in-house. It will take minimum 3 years and the failure rate is very high. You can do some use cases. You can select some problems, do in-house. These are called use cases, but not the entire supply chain. If you have to redesign, I mean, go towards the digital supply chain, you better embrace the solutions that are already available in the market. Don't develop it in-house. Netflix also, how much big data is flowing into the Netflix based on the viewers' preferences, how they analyze this users' characteristics, and what is their viewing patterns, and then analytical engines, they process all this big data and give recommendations. I mean, recommendation engine is separate, which automatically suggests what is the movie, what is the movie that you may like to watch next time. Like when you click on the Amazon, as soon as you select a product, the other two products pop up. You may also you would like to order these two things along with this product, like this. And when you select a book, automatically the nearest preferences are shown on the Amazon website. So these are all the Netflix entire Netflix is supply chain is digital. And the death of Blockbuster. When I was living in US, I lived in US for 12 years. I used to borrow the video cassettes. This was in 1995 uh, and 2000 also. So Blockbuster used to rent the DVDs or VCRs tapes, and then DVDs. But Netflix came from nowhere, and suddenly that we saw the death of the Blockbuster. With my own eyes, I saw shops being closed because there is not enough business. They failed to transform themselves into digital supply chain in the right time. That is a strategic mistake, and that's where Netflix entered in the right time, and they have perfected their entire supply chain and transformed this. It started as a DVD mail order type of business, but later on, the DVD itself became obsolete. Now nobody uses the DVDs, or nobody uses the the compact discs. All these things are gone. Everything became digital. So, so customers past purchase viewing patterns, how the customers rated the products, likes and dislikes, and all these things are, the advantages of the digital technologies. One more patent of Amazon I want to share with you, that is predictive shipping. Imagine a lady, a housewife with kids, and every month, let us say she is placing order for diapers. Obviously, diapers they don't want to store because it's a bulky item. Big packet arrives. They want to buy it once in a month, let us say. Now, what happens is once order is received, the software takes over. On the top side, you can see order entry. Order entry is done by the customer. Order management software takes over. Then manually or semi-manually, pick and packing is done. Then logistics department delivers the product to the customer. Suppose she has been doing this for 1 year regularly. Approximately every month, she is placing order for a particular diaper. Now the big data is flowing in. The analytics engine understands the pattern of that particular customer. Then for the next month, just before the end of current month, the order entry is done by the predictive analytics, and then the product starts moving towards the customer. Please remember that customer has not placed order yet, but the product is packed. It is moving towards the customer in the Amazon truck. What happens? They will call just 30 minutes before. Do you want to place an order for diapers? Usually, the answer is yes. There are statistics you can see on the web, but usually, and then if the order is placed within 30 minutes instead of 3 days or 2 days, within 30 minutes, order is delivered. If the customer rejects due to some reason or the other, it will go to a local warehouse, wait for next customer. It could be same lady or some other person. What I'm trying to say is that how do you reduce the lead times? By leveraging the digital technologies. Amazon has got patent for this also. This is called predictive shipping, anticipatory package shipping. This is the patent number. These are all the patent pages which they're all publicly available on Google. You can search and find. I'm just showing, I'm not explaining these things because we don't have time. So these are some pages of that patent, predictive shipping. So finally, this is the evolution. So analytics in 1980s, the question was, what happened? That is called reporting. And in 90s, why did it happen? Lean and Six Sigma, you can imagine. They always go to the source of the problem. So that is a Lean and Six Sigma. Why did it happen? And you solve the problem. In 2000, year 2000 onwards, what is happening? That is the real-time dashboards are slowly coming. They started coming because of the internet, mainly internet, and slowly smartphones started coming. And then now with the millions of software, so smart devices all over the world, big data has come. So the prediction is possible with the algorithms. So the question here is in 2010s onwards, what will happen? So that is the predictive analytics. It will, we saw how Amazon leverages the patterns in the purchases by the customers, and then does the predictive shipping. Now, I want to give another example that is called digital twin. Digital twin is the replica of the your supply chain. You have physical supply chain. Imagine the trucks, number of trucks you have, the physical people who manage the supply chain. All this will be digitally codified. And if you want to do some experiment, you do on the digital twin. Then if the results are successful, then you implement on the physical supply chain. Because the world is experiencing great uncertainties, vulnerabilities. For example, this is the COVID map. And there was a strike when I lived in Los Angeles for about say 5 years. During my career there, there was a port workers strike, which went on for months actually. It was called Longhorn strikes. Many ships waited for months because the containers could not be unloaded without the workers. That was an uncertainty. Then SARS virus, you all know, it came long back in 2003. So the digital twin, to give an example, for example, Singapore is a city state where it has a digital twin of the entire state. So they want to, suppose they want to build a flyover to ease the congestion, traffic congestion. They do it on the digital twin first. See if it is effective or it will be effective. If it is effective, then they'll go and build it physically. So GE engines also, digital twins are there. Any modification on the physical engine will be replicated on the digital twin, so that real-time monitoring, data, health, reliability, maintenance, spare parts change, and all these things can be in advance communicated to the customer in advance. Okay, some drug companies are trying to create human beings digital twins also, but it will be long before such a dream is realized because human body is very, very, very complex. So this is the diagram which shows you. On the right hand side, what you are seeing is the physical supply chain. Okay, physical supply chain encompassing supplier, factory, wholesale on the right hand side, wholesaler and retailer. On the left hand side, you are seeing the cyber supply chain or digital supply chain. In between these two, what you are seeing is optimization and simulation modeling engines based on artificial intelligence. So whatever you do, you want to do on the physical supply chain, suppose you want to add more trucks, let us say, or you want to implement predictive shipping, or you want to increase the number of people, or you want to increase the number of warehouses, whatever you want to do in the physical supply chain, that first experiment on your digital supply chain and simulate it, see the effects. If the effects are beneficial, then you can go and implement in the physical supply chain. Not only that, for example, we do not know what kind of corona problem world will face, like coronavirus in future. 10 years from now, coronavirus may go in another 1 or 2 years. but something is some mutant, some other thing can come maybe after 5-10 years. We don't know. And also imagine the climate change problems. Many ice is melting very fast. Ice, in polar regions, Arctic, Antarctic ice is melting very fast, and the net carbon emissions are not going to decrease drastically for another at least 30-40 years. The temperature of the earth has already gone up by 1.1 degree, and it will surely reach 1.5 and even touch 2 degrees. Then drastic things are the problems will be on the humanity. This is due to climate change. SARS type of virus or the COVID virus comes quickly, but the problems of due to climate changes, they come slowly in disguise. Slowly they come, but they also will be huge problems. For example, your supplier is somewhere in the port city. Suppose he has to, suppose the city will be submerged due to the rising sea levels. What will happen to your supply chain? You want to experiment that? Then do it on the digital supply chain. Map your supply chain. Identify the suppliers who might face climate change risk. Then do the experiment on the digital supply chain. Then physical supply. You implement those decisions, finding an alternative supplier or asking your supplier to move to a higher ground or whatever. No, those things you can imagine. Infinite possibilities are there. Do the physical supply chain. So these are the so basically a digital twin of your supply chain will focus on optimization, then simulation, then data analytics. So you become more resilient. Your supply chain becomes more resilient and more agile. So this is the summary of digital supply chain. Okay. So let me skip some of. And also you can stress test your supply chain. What is the concentration of how much spend is there on the various aspects of your supply chain? What is the supplier interconnectivity? What is the supply chain depth? What is the dependency? What is the substitutability? What is the visibility? So this kind of stress test you can do on the digital supply chain. Even a short disruption of 30 days or fewer can put 3 to 5% of EBITDA margin at stake. That's why stress test is an important aspect of digital supply chain, which you can implement on the digital twin, as a digital twin. Now, last aspect, I am coming to the last aspect, that is, once you have transformed your supply chain, traditional supply chain, into digital supply chain, by using all the technologies, available technologies such as sensors, connectivity, big data, analytics, artificial intelligence, machine learning, augmented reality, virtual reality, 3D printing, and so on, robotics, cobots, and all these things. New business models emerge. Let me give one example. I had the opportunity of listening to Sri Venkatesh Natarajan, who is the Chief Digital Officer at Ashok Leyland last November. So there, here you can see the picture. This is our classroom at ISB, and these are part of this lecture is a part of our distinguished speaker series. And Ashok Leyland has Chief Technology Officer and Chief Digital Officer. These two are separate positions because Chief Technology Officer takes care of IT and that kind of stuff. Chief Digital Officer role is how do you maximize revenue using the data that you have about your customers, about your products, about your supply chain, and so on. Here you can see Dr. Chandan Chaudhary introducing the guest distinguished speaker, Sri Venkatesh Natarajan. And what I learned from him is has become very valuable to me. This was 1 year back, and this is the summary. The average purchase price of the truck for the customer is 25 lakhs. but the total cost of ownership over its life cycle is 4 crores. The costs are fuel, tires, spares, maintenance, repair, and so on. Now, before the digital technologies, in the traditional model, business model, the revenue for the company, Ashok Leyland, is 25 lakhs whenever it sells a truck. It doesn't generate any revenue from the fuel, tires, spares, maintenance, repair, etc. Maintenance, they may be deriving some benefit through the service centers, but the entire thing is transformed digital with the digital technologies. Now imagine that engine has more sensors than what it was before the digital technologies. Ashok Leyland engine has 36 sensors now. Similarly, the truck, fuel tank, and all these various parts, drivetrain, suspension system, and gearbox, clutch, and all these things, they have sensors. Now, with these sensors, the health of the truck can be constantly monitored. Which spare part is likely to fail? Which part of the truck is likely to fail? Predictive analytics, predictive maintenance, or what is the fuel consumption? Is it according to rated fuel consumption, or is it more or less? What could be the problem? Diagnostics and so on. So once they started selling these trucks. Now, for every truck sends a lot of data to the cloud. And Ashok Leyland accumulates this data. They developed algorithms. Then now they developed 4 apps. One is Lakehart. These are all these 4 apps run on the smartphone. And if a truck fails somewhere on the road, and it needs a spare part, the driver can just take his smartphone, go to this website, Lakehart, and place the order for the spare part. It is 24/7. The spare part will be delivered to the location of the truck where the customer is wanting the spare part to be delivered, or to the location where the truck is stranded. This is one app. Second app is the Service Mandi. Service Mandi connects the customers with the Ashok Leyland trained staff. If there is a problem, Ashok Leyland trained qualified mechanics can advise how the problem can be solved. They can advise the driver or the mechanic. The third app they have developed is iAlert. This is vehicle tracking and vehicle health monitoring in real time. For example, one particular truck, the fuel consumption was high. So the owner of the truck was losing about 4 lakhs extra money every year. They fine-tuned, solved this problem, and he saved that money. Some part of that comes to Ashok Leyland. That's extra revenue. And e-diagnostics. The troubleshooting list based on artificial intelligence pops up on the smartphone, and the driver or the mechanic of the vehicle can give some cues, and the artificial intelligence will pop up, and also possibly it can connect to the Ashok Leyland expert mechanic. No, this is the 4th app. Now, what is this? What is the implication? Extra revenue for the company. Previously, before the digital revolution, they were making only 25 lakhs whenever they sell a truck. Now it will be much more. I don't know the numbers, but because the cost of ownership of the truck is 4 crores over the period of its lifetime. So data is the new capital. Data is the new capital. Once you have data, can you generate revenue based on your data? So this is the implication. This is the new business model. I gave one simple example, which is already implemented by Ashok Leyland, but there are several examples how data leads to new business models. So this is the group photo of with our students. You can see our executive director, Dr. Chandan Chaudhary, and our associate director, Colonel Rajiv Bhargava, along with Mr. and Mrs. Venkatesh Rajan. This is our class of 2020. We bring in distinguished speakers to our program, advanced management program in manufacturing and operations, to get our students to up to date. Get thrilled. Because teaching is not filling a bag, but igniting a spark in the creative spark in the minds of the students. There could be a lot of metrics. Let me skip this. These are all available online. You can see there could be a lot of metrics, SEM metrics, but benefits of the digital supply chain will be in terms of time, in terms of cost, in terms of labor, in terms of waste eliminated, in terms of emissions. For example, the emissions of trucks can be monitored in real time. The factories, what is the carbon net carbon footprint of the factory? That can be monitored with the help of industrial IoT, industrial Internet of Things. So basically, there are a lot of things, but let me summarize that there will be 20, bottommost, you can see, this is from McKinsey report, 20 to 30% R&D efficiency, 5 to 8% improvement in material cost, cost reduction. Manufacturing cost reduction will be from 5 to 15%. On time in full improvement will be 20 to 30%. And full-time equivalent productivity will be 45 to 55%. So like this, there are a lot of benefits. So as a last example, I want to tell you that the supply chain, digital supply chain, whatever you are understanding, you can understand if you digital supply chain better if you understand the human body. This is what Colonel Rajiv Bhargava mentioned during the introduction. That is the nature's example, or their supply chains in nature. Are there digital supply chains in nature? The answer is yes. Much more efficient than what we find in the human world. So basically, we start with sensors. Recollect one of the earliest slides in my PPT today. The bottommost layer is sensors. For example, on your skin, human skin is about 2 square meters. It has 2 billion sensors. You will not believe, but you have to read a medical textbook. I read medical anatomy book. That's why I'm able to share these things with you. You have 10,000 taste buds. You can taste millions of substances. And each taste bud has taste receptor sensor. Which is called TRC. TRC stands for taste receptor cell. There are totally 1 million of the sensors on your tongue. Okay, there are 6 million to 10 million sensors in the nose, and in the human ear there are 30,000 sensors for the auditory, and for the vestibular there are 20,000 sensors. In your eye, you will not believe these numbers, but no factory has so many sensors, no supply chain has so many sensors. Human body looks small, 6 foot tall, but actually it's a very complex system. And sensors are 131 million in your eyes, 125 million rods, 6 million cones. Okay, each eye is a 288 megapixel camera mounted on a tripod, automatic tripod. And inside your body, muscle spindles are there, they are sensors. For example, when you are moving your hand, suppose you close your eye, you move your hand, but without seeing where your hand is. So that is all possible because of the sensors in the muscle spindles. So all in all, inside our neocortex, there is analytics engine, there is a memory to store big data, and big data means from your childhood. We remember a lot of data, and some physicists who work with physicians estimated that our memory capacity of the brain is about 1 million GB. That is the memory capacity. These are crude estimates because brain is not like our hard. It's not like exactly like computer. It is much more complex. So in your brain, there are a lot of things happening which can be related to Internet of Things or Factory 4.0. Yet the brain material cost is only about 40 rupees because it is 80% water, 12% fat, 8% protein, and traces of ions. If you take an advanced humanoid robot like Asimo, there may not be more than 200 sensors. But in your body, there are billions of sensors. Okay. The cell is the building. I am coming to the supply chain. What is the supply chain example of nature? That's where we started. Your body consists of 30 trillion cells or so. And these 30 trillion cells, each cell is very complex for factory by itself. And if you want to understand the complexity of the cell, you have to read this book, which I read long back by Nobel Prize winner Christian D. Dubé, who won the Nobel Prize in 1974. So cells, when they come together, they become tissue. And tissues, when they come together, they become an organ. Okay. These organs become systems, like circulatory system, or the muscular system, or skeletal system, or the nervous system, and so on. These systems become organism, like human body. I will give one example. Every factory, cell is a factory, and every factory needs, there are 30 trillion cells in your body, and every factory needs food. Food means oxygen and sugars, basically. So this is your digestive tract. And whenever you are hungry, what happens is the body generates one hormone. It's all micrograms. Please remember, human body ultimately works on electricity, but it is chemical-based electricity. It is not like electromagnetic electricity, no, based on motors, dynamos that we generate in thermal power stations or the nuclear power stations and so on. So it is based on chemicals. So ghrelin, when it is secreted, when the cells are dying, when cells are craving for energy and oxygen, water, the ghrelin hormone is released. You feel appetite. You feel hungry. Then, as you start eating, the amount of ghrelin depletes, and as you start eating, your appetite gradually decreases. Well, what is the implication? You can see the ghrelin as a Kanban, let us say production Kanban or supplier Kanban. Supplier Kanban means you go and bring the raw materials. So the number of Kanbans indicate the quantity that should be delivered. Each Kanban has a fixed quantity. I'm sure all of you who have implemented lean, I have implemented lean in many factories. I know what all this is about, but I'm relating this to your human body so that you can apply the supply chain concepts and you can understand supply chain concepts better. So like this, then hypothalamus controls the body temperature, hunger and fatigue, okay, and sleep. Then frontal lobe makes the decision what food to eat, which restaurant, where, in home or outside, all these things, frontal lobe, where intelligent decisions are made. They make the decisions. Then hippocampus, they stores the memories of which food you like most, which food you don't like, and all these things. All these interact, and then two hormones, ghrelin and leptin. So ghrelin quantity will be increasing when your cells are craving for sugars, water, and so on. Then as you start eating, the amount of another hormone called leptin increases, the amount of ghrelin decreases. These you can see the two types of Kanbans. One is supplier Kanban, another is the production Kanban. Production here in the sense, no, you are eating food, so you are consuming food, you are supplying food inside to the stomach. So you can observe, and no, this is how body works. And then if you, this is the, and also you need insulin, to control the delivery process. I will not go into that because of time, but it's very interesting. Nutrients have to be, for every cell, nutrients have to go in, waste must be picked up, picked up. So there is, for every delivery, there is a pickup. That's what you have to understand. When you look at UPS, for example, normal delivery is 16 million per day. Peak is 28 million per day during the Christmas season, such as this month. But our body, the heart, pumps the blood, blood which is deoxygenated, goes into the lungs, exchanges carbon dioxide and oxygen, and picks up oxygen, and then travels to every cell and delivers the oxygen and nutrients. So total length of blood vessels in your body is about 100,000 miles long, or 170,000 kilometers long. I mean, please relate this to the length of roads where your supply chain entities like trucks are traveling. So pumping volume is 5 liters per minute, or per minute, and normal circuit time is 1 minute. Deliveries to the 30 trillion cells. Each cell is a factory. Please remember that is 9 into 10 power 15. It is huge deliveries, and every delivery has a pickup. That's what you have to understand. This is equivalent to 320 million times that of UPS deliveries per year. That's what you have to understand. And then deliveries has to be increased, decreased depending on your need. Suppose sometimes you need more energy, more nutrients. So heart has to pump faster. Your blood pressure goes up, such as this person who is crossing the road and so on. So, or when you encounter a snake. So let me skip all these things. The variation in UPS deliveries is about 2x, 14 million per day to 28 million per day during Christmas season. But your deliveries can vary by 7x, 7 times. That is the ingenious design of the human body. Okay. So finally, this is my final slide related to digital supply chain. 3 top trends is data visualization, increased visibility into the supply chain, and demand sensing. These are the 3 major supply chain trends. So a report by Gartner said that at least 50% of large global companies will be using AI, advanced analytics, and IoT in supply chain operations by in another 3 years. So that is the report. And if you do not have much time, if you are working in companies which have not thought about this, then you better start immediately. Otherwise, you will be late. You will be out of business. So this is basically the major advantages will be the agility of the supply chain will go up, your costs will come down, your inventories will come down, your service will be better. This is the summary by McKinsey. So anyway, you as an individual, you need to learn a lot in case you are not learned these technologies. What you need 3 characteristics: your will to learn, your skill, how fast you can learn, velocity, how quickly you can change yourself with the technology trends happening inside these are 3 dimensions of learning. And here at ISB, we practice all these elements in our advanced management program for manufacturing and operations. And we have this program is a 12-month modular program, which involves classroom learning, online learning, self-study, and action learning project, along with guest speaker series, such as the one I mentioned just now, ventilation Trojan of Ashok. So this is a term one which you teach general management, which consists of fundamentals of economics, statistics, finance, negotiation, change management, management of teams, and fundamentals of marketing. But we are not, that's only term 1. But remaining 3 terms will focus on the latest things like technology strategy, emerging topics in manufacturing, all the technologies that we have discussed, manufacturing planning and control with the 4th industrial revolution era, data science, supply chain analytics, systems analysis and optimization, strategic management, of operations, strategic procurement, innovation and product design. I like this. So, and marketing. We bring in all the latest things into this course, and then in second term, third term, fourth term, or will teach the latest things. And then action learning projects. You have to take up a project in the first term itself, and you have to progressively implement this project uh, with your team members. Usually, we divide the students into 4 to 7 students in each group. You have to implement this selected project under our guidance. Our guidance will be available to you 24/7. So you have to implement it, show the results, what exactly you have learned in the AMPMO program, Advanced Management Program, and what exactly you have achieved by implementing the solution. What is the savings? What are the benefits? And so on. So our program, next program starts on January 29th, 2021, just no, 1 month from now. That is the first term. First term will be on the hybrid mode. Those who want to do online, they can do online. Those who want to come, they can come. Everything will be communicated to you in case you enroll. And then the remaining 3 residencies, we will watch the progress of the coronavirus and its mutants, the variants. Depending on the progress of the coronavirus, we will take decisions for regarding the hybrid model or on-campus model for the residency 2, 3, and 4. So this is a 1-year modular program. Basically, we focus on this. How do we modify our way of thinking? That is what our focus will be during this advanced management program. How do you transform the team or entire organization? So the scientific thinking is what we teach, coupled with the most advanced technologies. Okay, to quote Mike Rother, it involves running a comparison between what you predicted, what you predict will happen next, and then seeing what actually happens and adjusting based on what you learn from the difference. So this is the core of our teaching, I can say, at ISB. The previous participants, we had extraordinary participants and their feedback, which you can see on our website. There are a lot of benefits for the individuals and the companies who join this program. It's a world-class faculty. Who, besides ISB faculty, we have faculty from the many US universities and from Europe also. They are excellent faculty. You know, they have done a lot of research and they are cutting edge technologies. They embraced cutting edge technologies, and the companies which sponsor, they will get great benefit by the learnings, which can be translated into the savings and business growth or change management and so on. Then you can see the class profiles. This last year, the last passed out batch, we had the average experience of the class is 16 years. Engineers are 58%, non-engineers are 42%, undergraduate are 94%, postgraduate are 6%. This is a class profile. And once you complete this course, AMPMO, you will become part of ISB alumni, and then you lifelong alumni, and you will have a lot of opportunities to network with ISB alumni. And then this is our website. You can go to just isb.edu, type AMPMO, you will get the details, you will get this brochure and all the details. This is one of the classes where I took. You can see me along with Chandan Chaudhary. I taught one course called New Product Management for the last batch. And I had a thrilling experience with them, because they are all experienced people. They are not freshers. We don't take freshers. We don't take fresh students from the college. We take students minimum with a minimum of 5 years experience. So this is the group photo of myself with my students. It was so happy to interact with them, to guide their action learning projects, to share our knowledge, and to visit their factories if time permitted. Some factories we visited actually to see their projects live, how they are performing. So this is one of the happiest moments in my last year's academic career. And then we also bring in, as I told you, a lot of distinguished speakers. Here you can see Harish Chavan, who is the managing director of Swaraj Tractors, being introduced by Colonel Rajiv Bhargava to our students. And he spoke on simplicity. It's a beautiful lecture. I learned a lot, believe me. How they reduced number of transmissions from 16 to about 7 or so. So this is myself and Colonel Rajiv Bhargava presenting a memento to Sri Harish Chavan. And then the students presented action learning project. This is one picture I'm showing you. We have hundreds of pictures like this. This batch did a project, One Village, One Crop. How to implement One Village, One Crop towards achieving sustainability with industrial Internet of Things, IIoT, and latest technology, leveraging artificial intelligence and all that stuff. So this is the picture of one of the batches presenting their action learning projects. So this is what we do. And really, those of you who are listening to me, I want to tell you that this ISB is a world-class institute. And if you want to enroll in this course, please visit our website, get in touch with our staff, and then we are doing our best to offer you the world-class program called Advanced Management Program in Manufacturing and Operations. Thank you for your patient listening. And in case you have any questions, if I can answer, I will try to answer. Thank you.
Thank you, Professor Pratap. I think the real life examples that you have given I'm sure have driven a lot of value and a lot of understanding amongst the people who are listening. And also the way you have connected digital supply chains and digital continuity to the human body is something I feel is very unique. One is, I think, Munish Gulati, who asks, how are security and privacy issues harmonized between the manufacturer and the client as relating to access to big data? If you can answer that. And there are there is one more question after that.
Yeah. There are a lot of security solutions. Blockchain, for example, I did not cover blockchain today because of the time. But if you read something about blockchain offers this type of security and protects your data from vulnerability. So there are a lot of security solutions, companies like IBM, Cisco, and all these many people, big players, they offer security solutions, Google and so on. So you between the manufacturer and the supplier, if you want some understanding, you have to come to an understanding. What is the both of you would like to achieve? There should be a win-win situation. It cannot be exploiting the supplier by the manufacturer, or some big suppliers, they exploit small manufacturers. It should not be that way. It should be win-win situation. You have to come to an understanding of what data you can share. And you can use blockchain, which I did not cover today, but you can read it on Google, see it on YouTube. So blockchain is one technology which will help you to solve this problem. Thank you.
Right. I think, thank you. That was a quick and comprehensive answer. Then we have a question by a gentleman by the name of RR, and he is talking about the same, the comparison between just-in-time and the reliance of resilience of these supply chains. He says that predictive shipping and other such initiatives generally achieve the benefit by moving supply chain towards just-in-time. However, just-in-time and supply chains are opposite. So how do we improve efficiencies of just-in-time during these COVID times and the other such pandemics or black swan events which are inherently unpredictable.
Yes, thank you, Mr. RR. See, just-in-time deliveries are based on customer orders. It is not based on predicting what customer wants and taking the product to him. No, it is not based on prediction. It is based on confirmed customer orders. So, for example, I was working for a company which supplies parts to Toyota. Toyota places an order, fixed order, and they have to deliver that only, not less, not more, not different, on time, 100% quality, 0 ppm, and so on. But predictive delivery is different, because in digital supply chain now you are able to understand the customer behavior, and because of the digital technologies in the just-in-time environment, digital technologies were there, but they were minimal. Mostly we used, for example, in my company, I worked as director of manufacturing for an American company in Los Angeles. So I implemented Lean, and this was 20 years back. And then we implemented all physical, like physical Kanbans, supplier Kanban, physical production Kanbans, physical withdrawal Kanbans, and so on. And it was not based on digital. Now digital Kanban, you can implement digital Kanbans. Now, slowly, because of the digital technologies, just-in-time will become more and more efficient. For example, in the paper Kanbans, there were some problems like losing a Kanban. See, some worker, he wouldn't like this new system. He destroyed one Kanban. Such things will not happen in the digital world because you cannot destroy a digital Kanban. So there are a lot of commonalities, but there are a lot of differences. And the just-in-time deliveries will only improve better and better with the digital technologies. That's my answer. Thank you.
Right, thank you. So Suresh Kapiti made a statement that the faults in sensors and cyber security aspects will give some challenges to digital continuity. And Gulshan Sweka has another question, and that is, if enterprise wants to convert from operations to digital, what could be the step for this transition?
So regarding the first question by Suresh, I would like to tell you, yes, what you mentioned is true. Cybersecurity is a major problem. But a company, because of the cybersecurity issues, cannot stop implementing digital supply chain, because the best companies are already moving forward. No, I mean, they have already moved, and you do not have much time to transform your company. There are only these problems will be there. Cybersecurity problems will be there, and all these problems will have solutions, and again problems, again solutions. This will be there continuously. So, but there is no option but to adopt digital technologies for your supply chain. That's my first my answer to the first question. Otherwise, you may go out of business actually. So because of low efficiency, low productivity, high inventories, so you have no other option except to go for digital supply chain. Second question is related to what Rajiv, that lady, Swapna?
That was, uh, I'll tell you the name. This was Gulshan Swaika.
What is the, sorry?
If enterprise wants to convert,
Yeah. Roadmap. Yeah, roadmap.
the roadmap to convert to digital.
Yeah. So, enterprise, top management, the leadership of the company must prepare a roadmap. What is that they would like to achieve? This they can do with the help of a consultant like McKinsey or Deloitte, or very many people are there. So they will do the road mapping. Then you have to come out with the implementation plan. Road mapping is the first, and it should be done by top leadership of the companies. That is the first thing. Then they can also do one second thing, that is they can select pockets where digitization can be done, and these use cases can be prepared. Use cases can be prepared. For example, I let me give you an example. Tata Steel at Kalinganagar is selected by the World Economic Forum. Tata Steel in Kalinganagar, Odisha. So they have selected Tata Steel as a lighthouse of global manufacturers. A World Economic Forum has selected 54 companies only, and only one company from India got selected because of the digital initiatives that they have taken, because the maximum number of use cases that Tata Steel has already implemented and published. Thank you.
And the last question for the day by is Vasam Shetty Adarsh, who says on the same again on the just in time, when the question is that when manufacturers volume drops, what happens to the intent of GI?
See, volume drop could be due to COVID, or I'm guessing during these difficult times, many companies suffered because of the lack of orders. We did a lot of research at ISB along with our executive director, Dr. Chandan Chaudhary and Colonel Bhargava. So these are difficult times. Yes, they scaling up is difficult. Scaling down also is difficult for many. Suddenly, you cannot scale down. You cannot reduce the number of machines. You cannot reduce the number of people. But some cost-cutting measures, as many companies have taken, like salary cuts or so many measures were taken because of lack of orders, because of low volumes during these COVID times. Many cost-cutting measures were taken by the companies. Such measures should be taken in order to survive until this pandemic goes away. Thank you.
Thank you very much, sir, for this for an enlightening lecture. I think 2 hours went away without even anyone realizing. I have with me Professor Chandan Chaudhary, who is the Executive Director for the Munjal Institute for Global Manufacturing. Professor Chandan, would you have a few words on this?
Yeah, good evening, everybody. Professor Pratap, I want to thank you for the excellent talk on digital supply chain. And those who are still connected, I wanted to tell you that digital is no more a niche skill. It has become an integrated skill which is required for managers to be very, very successful. And I think what Professor Pratap was telling, our advanced management program, we actually train senior executives on how we should go about doing transformation in a manufacturing and operations ecosystem. So our focus, for example, when we talk about digital supply chain, is not just automation. It's about transformation. How do you leverage digital technologies as an enabler to transform your business, to make your business globally competitive? And in fact, in our course, when you go through our course, you'll end up becoming somebody who is equipped and familiar with the tools and techniques that you need to be able to make an objective assessment of your organization, performance of your organization, and come out with a step-by-step approach as far as improvement strategies are concerned. And for example, when you talk about digital supply chain, you would learn how do you assess digital maturity of the organization? How do you assess digital leadership capability of the organization? How do you assess digital capability of the organization? So I think the tools and techniques that we expose our executives who go through our program, they're very, very interesting. And I think it's increasingly, it's becoming important that we upgrade our skill. And those who are ambitious, I think advanced management program is a great opportunity. So thank you everybody for joining this call. Professor Pratap, thank you very much.
Thank you, Dr. Chandan. Thank you, Colonel Bhargava, for all the help. Thank you so much.
Thank you, everyone. Have a great evening. Enjoy your Sunday. Thank you.
Yeah. Happy New Year to all of you. All the best.